few factoring problems that I gave on Friday for review. The worksheet is Math 10C factoring practice. I'll go over a few on the 5th page, the one titled Mix Factoring. So I'll be referring back to this flowchart quite a bit throughout the video here. You want to start here and kind of move along to each decision and see what you need to do next. So it's a good way to organize how you should factor anything. So let's get started. Right, so the first question here, we've got 3x squared minus 48. So first thing you want to do is try to pull out a greatest common factor. And so the biggest thing that you can pull out of these two terms, turns out you can pull out a 3 from both of these. So you got x squared left for the first term and 16 left for the second. So if you distribute this 3 back in, you get 3x squared and minus 48. So you get back the original expression. So there's your greatest common factor done. There's step 1 done. Next thing you need to ask yourself is how many terms are there? There is 2 terms, and it looks like a difference of squares. So we have something squared minus something else squared. So we can write it as x plus 4, x minus 4. And we're done. So if you want to check this, I'll just write that in different pen color. X times x gives x squared. X times negative 4 is negative 4x. 4 times x is positive 4x. And 4 times negative 4 is negative 16. So 4x and negative 4x cancel out, so you get x squared minus 16, which is there, and then 3. So there's that one done. Alright, let me just switch colors here. Alright, for the next question, a cubed plus 2a squared minus 35a. Again, first thing you want to do is see if you can pull out a greatest common factor. So the biggest thing that all 3 of these have in common, looks like you can pull out an a from each of these. They all have at least one a. So this is the limiting one there. Since that one only has one a, I can only pull out one a. So a leaves me with a squared plus 2a minus 35. Okay, now how many terms do we have? We've got 1, 2, 3 terms, and the coefficient here is equal to 1, so it's a basic trinomial factor problem. So we need to find 2 things that add to give 2 and multiply to give negative 35. So we can search for factors of 35. Factors of 35 are 1 and 35. 5 and 7 work as well. So the sign here on this guy matters. So when we multiply 5 and 7, we need to have one of these being negative and the other being positive. Because if they were both positive, then we don't get a negative. And if they're both negative, then this is positive as well, which isn't good. So we want these. It looks like we can arrange them to add to 2. We need to pick the 7 to be a positive and the 5 to be a negative. So the factors should be negative 5 and positive 7. So to check, we do a times a, we FOIL it, right? So a squared a times 7 is 7a. A times negative 5 is negative 5a. And negative 5 times positive 7 is negative 35. So 7a minus 5 give us positive 2, which is good. And then we get minus 35, and then the a squared as well. So that's fine, and that works. Right. Go to the next question. 4m squared plus 11m minus 3. Now, with this one, we can't take a greatest common factor. We can't take a 4 out of these 3. We can't take a 3 out of them. We can't take an m either. So, looks like we have a trinomial with the first coefficient not being 1. So, a number of ways we can do this question. We can, first of all, might as well try out to see if it's a perfect square trinomial. So that means that you could write it in this form. You could factor it like this. A plus b times a plus b. Now this would require this to be a perfect square as well as this one. And it's not. You can't have something times something give negative 3. Something times itself giving negative 3. So that doesn't work. Right, so you can do either trial and error or the X factor method. I'll just go do a so you can do trial and error with this question. You need two things to multiply to give 4m squared at the front end. So you can try 2m at the front of one binomial, and you can try 2m at the front of the other. So 2m times 2m will give you 4m squared, so that's fine. Now we need to find two things that will multiply to give negative 3. So you can choose possibly positive 3 here and a negative 1, for example. But if we try this, 2m times 3 gives positive 6. Negative 1 times 2m gives negative 2. So that would add to give negative 4. Sorry, positive 4, which doesn't equal 11. So this choice is no good. So that was a bad choice. Let's try another. We could do negative 1 and positive 3. Just did that one. We could also try swapping them. So then we would get basically the same thing. Negative 2m plus 6m is positive 4m. What else can we do? We can try flipping the signs. So we could do a negative 3 here and a positive 1 there. But this would give 2m minus 6m, which is negative 4, which doesn't work out either. So let's try picking a different front end here for each of these. So we can do 4m and m. These still multiply to give the front, which is good. So 4m times m is 4m squared. Now we need to find the back ends that multiply to give negative 3. Again, we can try negative 3 and positive 1. Positive 1. So now the back ends multiply to give negative 3, which is good. The front ends multiply to give 4m squared. Now we need the middle terms to add to give 11. So let's see that they do. 4m times negative 3 is negative 12m, and then 1 times m is just positive m. So this is minus 11m, which is sort of close. The sign is wrong though, so what we can do there is just try flipping the signs on these. So we could try a positive 3 and a negative 1 here. So front ends give 4m squared. 4m times 3 gives 12m. Negative 1 times m gives negative m. So 12m minus m give us 11m. And then the back gives us negative 3. So that one works. And one more example here. We've got x cubed plus 3x minus 2x squared minus 6. So you could try to pull out an x. This one's missing an x term though, so we can't pull an x out. It doesn't look like we can pull out any numbers beyond that. So we can't do GCF here. So how many terms do we have? We've got 4. We can't combine any of these. X cubed and x squared can't combine. X can't combine with anything either. So can't simplify further here at this point. So if we got 4 terms, we factor by grouping. So you can just pick 2 of each and just see if you can pull out a greatest common factor from those pairs. So pull out an x for the first 2. They each have an x. That leaves you with x squared plus 3. And then from the back 2, so remember this sign is applying to this term. So this is all negative 2x squared. This negative tags along with this term. So for the last 2, you can pull out a negative 2, and that leaves you with x squared plus 3. So when I distribute this negative 2 back in, I get negative 2x squared minus 6. And then just check that for the first pair as well. X times x squared gives x cubed. And then x times 3 gives 3x. So that's good. Alright. Now at this point, we have an x squared plus 3 and an x squared plus 3 in both of these terms. So it looks like we can pull out an x squared plus 3 from each of these. And then that leaves us with this one left behind, so x, and then this one is left behind as well, so negative 2. Now if I distribute this x squared plus 3 back in here to each of these terms, I would get back the original expression. And then it doesn't look like we can go any further with that, so that's good. And then it'd probably be a good idea to FOIL this, so just check that you get back the original question, and you should. So that one is correct.